Okay, what we're doing today is we are going to do. I know I had said I was going to have an experiment filmed, recorded. I do, but we're going to save that for tomorrow because I want to model what I'm asking you to do tomorrow. So what I did was I recorded a video of an experiment, but I kind of want to model what I want you to do a little bit here. So you should see a screen of someone who did a science experiment, and you can kind of see one of these trifold things behind here. And if you look closely, it says, does mint really cool things? And a lot of times with an experiment, you're trying to answer a question. You're not sure about something, you have a question. An experiment is a good way to answer that question. So I'm not going to play the audio, but I'm going to let this video play a little bit here and talk about what they're doing. So let's see what we have out here. She's talking about having a notebook or a binder because you need to record your data. You need to record everything with the experiment. Because a controlled experiment, well, there she was talking about asking a question, like, does mint really cool things? A controlled experiment you can repeat over and over and over again. And you've recorded everything here so that you could repeat it, or you could hand it off to someone else and they could, I'm going to stop there and make a hypothesis, they could do the experiment themselves. It's repeatable. The more repeatable an experiment is, the more times it's repeated, and you get the same result over and over again, then there's more validity. There's more chances that this is probably the truth, the science of it, that this is what's going to happen, or this answers that question. So keeping good records is extremely important because you don't want to do all these experiments and then have no record of it. And you also want to make them neat and understandable and organized so that someone else, anyone in the world, could pick that off the shelf and do it. And I tell you, that's one of the things that's probably the most difficult with experiments is that proper documentation. At least it is for me. I'm not really super neat. I'm kind of organized, but maybe not as good as I think I am. And it would need to be so that anyone could grab that experiment and repeat it themselves. So what we have here is she's doing an experiment about mint and about cooling. So I have, let me go to the right tab here. I have what her possible observation was. I believe at some point, and this is just my guess, when she put a mint candy in her mouth, it felt cool. There was this cooling sensation. So that's what her observation was. There was this tasting of this coolness. And maybe even she felt cooler. So this is what I think she said. When I put candies in my mouth, I feel a cooling sensation. So now I'm thinking she made an inference. And I'm thinking she inferred that mint, from that mint candy, reduces the temperature of water. Because I think she was thinking, I have saliva in my mouth, that's a water. I put mint in, the mint cools the water, so I'm feeling that cool water on my mouth. And that's not a bad inference. I mean, it seems pretty reasonable. I've had mint and it does feel like cool. And we know what cool feels like. That's our prior knowledge. So then I'm thinking this was her hypothesis. Okay, and we'll see why I think that. If, remember, hypothesis is two parts. If, and then it should be then. If then. If mint candies are dissolved in water, then the temperature of the water will decrease. And here's why I think, you can watch this now. Here's why I think this is what her hypothesis was. Right. So it looks like she has some cups here. She has them all numbered, which is good and organized. 1, 2, 3, 4, 5. So she's got 5 cups. Oh, almost had 4 there. Then she has some water. And she has it in a measured container, which is good. And she's going to pour all that in one. And now simulating that she's putting the same amount in each one. And then she's going to take her mint candies and she's going to put them in each of the cups. So she's talking about how she's going to put the mint candy, unwrap each one, and drop it in the cup. And then she's going to do that in each of the cups. So right now I'm seeing all the cups look about the same size. She said she's going to put the same amount of water in each one. But then she's going to put mints, and I believe she's going to put 2 in this one, 3 in this one, 4 in this one, 5 in this one. So there's some different trials there. Okay, and believe I see here, yes, a thermometer. And this is the tool she's going to use to observe the temperature. So she's going to take the temperature of that water, and she's running the experiment here and getting a readout of the temperature. And then she would get a temperature of the other ones with the mint in it to see if it is in fact cooling the water. And she would have to record that data in her notebook because she's not going to remember that. She's going to have a lot of temperatures, and she wants to remember that down. Now she's talking about rerunning the experiment. Generally, you want to do at least 3 trials 3 times. So she would do this whole thing 3 times because then you would have an idea of did it really work or not. So let's go back to my document. If mint candies are dissolved in water, then the temperature of the water will decrease. So what is our independent variable? We're trying to have just the mint candies in the water. Okay, that's our independent variable. That's what comes first. If mint candies are dissolved in water, independent variable, and the other term for that could be used is manipulated variable. So the second half of the hypothesis is going to be the dependent variable or the responding variable. It's going to respond to this. She is thinking then, if mint candies are in the water, then the temperature will decrease. Okay. Now, things that have to remain the same. So that way we only have one variable. And I took note of some constants. The cup size, the cup type, the cup size, the amount of water in each cup has to be the same. The starting temperature of the water, the mass or the size of the candies has to be the same. The type of candies, you can't have different, name brands. Maybe there's a different amount of mint in each one, so the same type. Time allowed between dissolving of candy and the temperature taken. You don't want to put some candy in, maybe have the temperature go down, and then come back and measure the temperature 30 seconds for one cup and an hour for another. You want to have that time from when they dissolve to that measuring the same. You want to use the same thermometer each time. So that way there's only one variable, and that is the mint candies in the water. The data she collected was the temperature. The temperature was collected. And that should be in Celsius. When we're ever using science, we're using the metric system. And for temperature, that's Celsius. The conclusion, I'm not really sure what the conclusion was. I don't know because she didn't really talk about that. She didn't really run the experiment. She was just setting it up. But my inference would be that that mint did not cool down the water. I could be wrong. That's just my guess. So I could do the experiment, and I could see myself. And then you could do it if you wanted to even. All right? So that's what you're going to do tomorrow. What you're going to do tomorrow is you're going to get a blank one of these. All right? You're going to watch the video that I created. Has to deal with one car, and a ramp at different heights. And you're going to take a guess at what I observed somewhere. I must have observed something in the past that could make me think of this. What did you think I was inferring? And then you want to make a hypothesis. So I'm going to give you a document you could write on. So you would start with if, and then what you think I changed. What did I change in the experiment? And then there'd be some space. Then, and you would then type, what do you think I was trying to measure then? If, then what, then this. What would be my independent variable goes here, and the dependent variable goes there. And then I want you to make note of what do you think my constants were. What were the constants? What did I have to keep the same throughout my experiment in order for this to be a controlled experiment? what type of data did I collect in my experiment? And what do you think my conclusion would be at the end of all that? So you're going to fill all this in, and then you're going to turn it in as part of the assignment. All right. Well, I hope that makes sense. I'll do a little explanation again. But for today, watching this video here that I'm doing and taking a look at this, okay, because this is what you're going to do tomorrow. You're going to do a little analysis of my experiment. All right. The Meet will be open the whole time. If you have a question, you can come back into the Meet, and I'll be there. Bye.